Welcome to this explainer. Today, we are unpacking the incredibly visionary prospectus of Kathmandu University's RAVI Lab. Well, if you've been wondering exactly where the next massive leap in robotics, autonomous systems, and visual intelligence is going to come from, you are definitely in the right place. We're going to explore a premier nexus for innovation that is meticulously engineered to operate right at the critical intersection of all these cutting-edge fields. And look, this isn't just about some abstract, high-level theory. It is about building a highly scalable, interdisciplinary ecosystem that actually solves real-world problems. All right, so here is our game plan for today. We'll start by pioneering the RAVI vision. Then check out their 3 pillars of innovation. After that, we are forging digital realities, diving into some real-world traffic projects, and finally, showing you exactly how you can join the mission. Let's get right into it. Section 1, Pioneering the RAVI Vision, Catalyzing the Future. We are kicking things off with the lab's overarching ambition, which is literally nothing short of completely redefining how autonomous systems interact with our physical world. Now, to understand their vision, you have to look at the lab's primary playground, which is the low-altitude economy. We are talking about leveraging state-of-the-art AI infrastructure to solve huge contemporary challenges, both down on the ground and up in the air. Think about it for a second. The airspace literally right above our heads is just this giant untapped potential. RAVI Lab totally gets that. By deploying drone-based systems, we can create intelligent networks that are highly scalable, secure, and incredibly robust. Whether it's inspecting critical infrastructure, monitoring a disaster zone, or mapping complex urban terrain, mastering this low-altitude airspace is an absolute game-changer for modern digital societies.
But here's the thing. To pull all that off, you need the right minds. This quote straight from the lab really highlights their pedagogical philosophy. It is not just about teaching students how to code a new algorithm. It's about cultivating capable, ethical leaders. The entire focus here is on application. They want visual intelligence to empower the next generation to go out and solve consequential, real-world challenges. They're training students to optimize agricultural yields from the sky or completely revolutionize how we inspect aging bridges and power lines. It's really all about ensuring these brilliant young minds are perfectly poised to tackle our most complex and meaningful problems.
Moving right along to Section 2, 3 pillars of innovation, the RAVI advantage. Let's transition from that grand vision to the proprietary magic, the actual strategic domains that give RAVI Lab its edge. So the real breakthrough happens when they fuse these 3 highly complex areas together. Under robotics and autonomous systems, they are developing next-generation agents that can navigate and plan their own motion entirely autonomously. Under AI and visual intelligence, they're building deep learning models that can actually perceive and reason about the world around them. But you know, the absolute secret sauce? That happens in data visualization and sensor fusion. Because, let's face it, the real world is incredibly messy. It's totally unstructured. So by combining the rich visual data of video with the depth perception of LiDAR, plus the all-weather toughness of radar, they're able to create intelligent platforms capable of operating literally anywhere. And what's really fascinating is how RAVI just leaps right past traditional methods here. In conventional deep learning, you're almost always bottlenecked because you need these massive, manually labeled datasets. It takes thousands of hours of human labor just to tell a computer exactly what it's looking at. Well, RAVI Lab is pushing hard into what they call omni-supervised frameworks. They are actively exploring semi-supervised and self-supervised paradigms. In plain English, that means they are creating super data-efficient models that seamlessly blend a tiny bit of labeled data with huge mountains of unlabeled data, and even throw in adversarially perturbed data to train highly robust systems. No more relying on entirely unexhausting manual data entry.
Which brings us to Section 3, Forging Digital Realities, Building the Twin. Let's see how all those fused technologies actually build into their primary research mandate, which is digitally replicating the physical world.
I want you to imagine having a perfect living digital copy of an entire city block, a sprawling agricultural field, or a chaotic traffic intersection. That is a digital twin. By learning from those vast unlabeled datasets we just talked about and inferring intricate causal relationships, RAVI Lab aims to build incredibly high-fidelity, dynamic digital twins. And just to be clear, this isn't some static 3D model. It is a living, breathing replica informed by that rich tapestry of fused video, radar, and LiDAR sensor data. This capability is absolutely pivotal for simulating outcomes, predicting real-world phenomena with jaw-dropping accuracy, and driving the next generation of immersive applications. Now, this massive ambition of forging digital realities spawns some really specific cutting-edge projects. For instance, they're pushing the absolute boundaries of multimodal video intelligence for low-latency, real-time analytics. They are innovating autonomous navigation in GPS-denied environments. I mean, think about it. How does a drone fly safely using just visual inertial odometry and LiDAR when the satellite signal suddenly completely drops out? It's wild stuff. Plus, they're deeply invested in adversarial machine learning. They're actually out there generating sophisticated digital and physical world attacks just to rigorously test their own models, ensuring these systems have robust AI threat detection and remain totally secure out in the wild. Section 4. Real-world traffic projects. The ground truth. Okay, so how does all this futuristic, high-altitude theory apply today, right now, down on the ground in Nepal? This is where we see the tech grounded in stark reality. RAVI Lab is deploying customized systems to monitor traffic right in the Kathmandu Valley. They're taking real-world video feeds, and look, if you have ever tried to navigate Kathmandu rush hour, you know calling it chaotic is a massive understatement. And they are architecting these highly sophisticated, real-time object detection systems to accurately identify, classify, and track both vehicles and pedestrians. But they aren't just plugging in some generic, off-the-shelf algorithm. The core goal here is to extend foundational, pre-trained AI models so they can actually detect custom objects specific to the incredibly unique context of Nepalese urban traffic. By doing this, the system essentially learns to identify intricate congestion patterns that are totally native to the area. This specific use case proves that completing these projects is definitely not just some academic exercise. It provides direct, actionable, data-driven insights for actual urban planning and management. It highlights exactly why this research matters so much on a day-to-day civic level. Finally, Section 5. Join the mission. Talent, partners, and philanthropy. With such high stakes, truly transformative work happening, RAVI Lab is actively seeking out the right innovators, partners, and backers to help scale their impact. So, if you are a Kathmandu University student 18 or older, and you've got intermediate Python programming and fundamental deep learning skills, this lab operates almost exactly like an exclusive tech incubator. You don't just sign up, you have to apply with a highly precise one-page CV and a targeted research statement outlining the concrete problem you want to solve and your methodology. Because they operate on a continuous cycle, you can jump in immediately the second you're accepted. And I love this part, the whole thing is essentially gamified. You have to successfully complete one project just to unlock the registration for your next one. It absolutely ensures that only the most dedicated talent keeps moving forward. See that number right there? That is the non-negotiable factor, commitment. If you want to be part of forging these digital realities and pioneering this low-altitude economy, you're expected to dedicate 10 to 15 hours every single week of unwavering, hyper-focused research and project development just to maintain your spot in the lab. This is an advanced specialization program focused purely on excellence, and it absolutely demands your full attention. Now, for those of you outside the student body, RAVI Lab champions a really powerful tripartite model of innovation, meaning they actively unite academia, industry, and governance. Under the leadership of principal investigator Dr. Pankaj Raj Dawadi, the lab offers bespoke collaboration opportunities, from joint research initiatives all the way to tailored talent development. And because knowledge in these quantitative fields advances at such an insanely exponential pace, they also heavily rely on philanthropic investments. Unrestricted gifts to their annual fund act as a massive catalyst, allowing them to rapidly acquire the newest equipment, fund groundbreaking student projects, and recruit world-class global talent to keep them right at the vanguard of innovation. So, as we wrap up this explainer, I really want you to think about the massive potential of the systems we've unpacked today. From fusing sensor data in impossibly complex environments to literally launching a low-altitude economy right from Kathmandu University, the groundwork for the future is being laid right now. Consider how your unique skills, your industry connections, or maybe even your philanthropic vision could plug into this incredibly dynamic ecosystem. The future of autonomous intelligence isn't going to build itself, so how are you going to help shape it?